Hello. Hello, everyone. A few announcements as people find their seats. First of all, please set your cell phones to silent. I remind people every time. So we have a few events coming up. Tomorrow, 2 o'clock, Friday afternoon at the movies, right here. And the film will be One Love, Bob Marley. Then on Monday at 2 o'clock, we have our film series starting, Ciné Club. On Monday at 2 o'clock, the film is Les Jours Heureux. And then Bright Lights Film Club with Gail Cohen is back on Tuesday. The film this week will be Past Lives, a South Korean film. Also next week, Thursday, Shakespeare in the Park, Infinite Variety at 6 o'clock in Ashkelon Garden. If the weather permits, if not, we'll be here in the auditorium. And I have two other big concerts. The 24th of July, mark your calendars, Rachel Terrien presents Latin Jazz Project in Trudeau Park. And then the 31st, concert in the park, Donald Godbout presents Koubli, which is Afro Jazz, at 6:30 p.m. Trudeau Park. So without further ado, here is Dr. Joe with Science Demystified.
Thank you very much. Welcome, and I have to be especially good today because I have three of my grandchildren watching here. All right, let's get going. Many of you, of course, watch Shark Tank, which is this interesting show where people come on and they try to promote some product that they hope the sharks will fund. Well, an interesting one came up, actually now it goes back a couple of years, and that was to do with ketchup. Better? Okay. That was to do with ketchup. These three guys were perturbed by the fact that whenever they ate a hot dog or a hamburger, they put ketchup on it, and the ketchup would squirt out when they bit down. So they wanted to find a way to solve this little problem, and they come up with sliceable ketchup. There it is, a slice of ketchup, and they actually founded a company called Slice of Sauce, where they sold this thing. And they got one of the sharks, because that they happened to be Alex Rodriguez, who was a former star baseball player, to buy into it. And they started up the company, and they started to sell this thing. Now it turns out that they were not the first people ever to think of sliceable ketchup. There was some research done on this in an Iranian university, where they published a study about the rheology of ketchup. Rheology is the ability of a substance to flow. So what they were interested in was finding a way to stop or slow down the flow of ketchup. Now, if you ever have looked at the label of your ketchup, notice that there being a number of ingredients there. One, carboxymethyl cellulose, is in there because it is a thickening agent. This is what makes the ketchup flow with a certain degree of smoothness. Well, they decided that they wanted to make a type of sliceable ketchup, so they wanted to find a material that would slow down the flow of liquid ketchup, and they experimented with a bunch of things: konjac, mannan, locust bean gum, gelman gum, and xanthan gum. What are these things? Well, glucomannan is derived from the root of a plant called the konjac plant. The other one, locust bean gum, is derived from carrot beans. These are used to make fake chocolate. Gellan gum is made by a bacterium. And this gum, xanthan gum, also made by bacterium. So they looked at these, and they found a combination that worked just right. They were never able to commercialize it. But interestingly enough, when I read this study, there was something that I learned from it, because they used a word in their publication called syneresis. which I had never heard of before. But it turns out that this is the expulsion of liquids from the gel. And if you've ever opened up yogurt, you'll notice that there's some liquid that comes to the top, right? So this is what they were talking about. This is what they tried to prevent. They didn't want ketchup to separate. But it just to show you that there's interesting research done in such everyday items. Although this never really went anywhere, it never became commercial. But tomatoes are very interesting nutritionally. Tomatoes are very rich in a compound called beta-carotene. This is interesting because in the body, it can be converted to vitamin A. And vitamin A is really interesting substance. I'll tell you a little bit about it, but for this, we're going to go back to ancient Egypt. In ancient Egypt, if someone had trouble seeing in the dark, they would go to the doctor and ask for some help. And the doctor would tell them to eat the liver of an ox roasted and crushed. Sounds delightful, right? Well, this is this is recorded in the Ebers Papyrus, which is about 1500 years BCE. That's an old document. Now it's preserved at the University of Leipzig. And what it is a compilation of ancient remedies that the Egyptians used, such as liver of an ox for night blindness. Okay, now this was not as ridiculous as you might think, because meat, especially liver, contains a lot of vitamin A. Night blindness can be due to a deficiency of vitamin A in the diet. So this is something that would have worked. But it took a couple of thousand years until this was discovered. Frederick Garland Hopkins was the scientist who discovered that liver and other meats contain substances that the body needs, more than just the protein, the fat, the carbohydrates. These substances came to be called vitamins, and he got the Nobel Prize for this. And eventually, Elmer McCullum isolated this compound, this vitamin A. He actually did it from liver. So what are vitamins? Vitamins are substances that our body needs but cannot make. So you have to have them in the food. Vitamin A is found in meat, fish, very rich, chicken, very rich. So basically in the developed world, we don't see vitamin A deficiency because people have a varied enough diet. And even if they don't eat meat, but they eat lots of yellow and orange vegetables, they consume beta-carotene, which in the body, as I mentioned, is converted to vitamin A. So it's very rare in North America to have a deficiency. And it is more likely actually to have an excess. If people think that a little bit of something is good, more is better, because vitamin A is what we call a fat-soluble vitamin. It's stored in the body, and it can build up to toxic levels. This is unlikely to happen from the diet, unless you happen to be an explorer who's stuck in the Arctic and have to resort to eating polar bear liver. Do not do that. If someone offers you polar bear liver, say no. Polar bear liver is the world's most concentrated source of vitamin A. It can kill, and it has killed. It has killed explorers. But again, since most of us are not in the habit of eating polar bear liver, we don't have to worry about that. But there are people who take vitamin A supplements. And again, they sometimes think if a little bit is good, then that more is better. And this is certainly not the case with nutrients. Vitamin A, you can't overdose on. It happens, it's very rare in North America. The bigger problem is vitamin A deficiency. That's a real horror story. Because about a third of the world is actually deficient in vitamin A, because the diet is mostly rice And rice does not contain vitamin A, neither does it contain beta-carotene. And this can result in all kinds of eye disease. Not only night blindness, but much worse, total blindness. And as I told you, much of the world is deficient in vitamin A. The areas that you see marked in red is where there is extensive deficiency. Now, that deficiency can be quite easily cured by giving babies vitamin A supplements, tablets. The only problem is that in those areas of the world where there's vitamin A deficiency, these are not the people who will take a vitamin pill. Difficult to distribute, and these are remote villages most of the time. It's just not a possible solution to the problem. But there is a very interesting scientific possibility, and that is to create rice that contains beta-carotene. And this is the rice that is referred to as golden rice because it actually looks gold. Now, this is rice that has been genetically modified to contain beta-carotene. Because what scientists have been able to do was to take a gene from a flower, a marigold flower, and put it into the genome of rice, and the rice will then produce beta-carotene. And this was a huge scientific breakthrough that was much heralded. And the Philippines, which has a big problem with vitamin A deficiency, were the first country to implement this and to allow this rice to grow until the activists got into this. And of course, organized all kinds of demonstrations trying to scare people away from eating this. This was totally ridiculous. This was decades of research which had shown that there's absolutely no issue here. But as you know, misinformation runs amok, and this certainly was misinformation, and resulted in stopping of growing of golden rice. Farmers also got into it because they thought that the seeds from the golden rice would drift into their rice fields, and then people would worry about eating their rice. I mean, it was all a lot of nonsense. And basically, this was a catastrophic situation because it actually led to children becoming blind and some even dying, all because of this ridiculous activism. But the story is not finished because the courts are getting into this and they may reverse this ruling. But anyway, it's interesting that, we started out talking about the Egyptians thousands of years ago who were giving the advice for night blindness to eat roasted liver, and they were right. Of course, they didn't know why, they didn't know hows and wherefores, but they were right. So some of these things that we see in ancient societies, they really turn out to be true. Not all. For example, the ancient Egyptians also thought that for blindness, we pour a mixture of pig's eyes, antimony, red ochre, and honey into the ear. And as you can imagine, that was not very effective. What happened is that the people who were blind now became deaf also. So not everything that the ancients did was good, but there were some gems out there. One of the most interesting of the ancient physicians was a Greek by the name of Dioscorides, who in the 1st century AD wrote the Materia Medica, which really was the first valuable book of medicine. In this, he cataloged the use of a variety of plants and talked about the poppy. The poppy, as you know, gives us opium, which is a great painkiller. He talked about colchicum. This gives us colchicine, which is a medication that is still used today to treat gout. Talked about squill. Squill contains digitalis, which is still used for congestive heart disease. We're talking here thousands of years ago. Now, of course, all of this was by trial and error, because if someone was feeling ill in those days, what recourse did you have? The only recourse was to try to eat something, right? So they tried all kinds of herbs and flowers, and Eventually, some of them actually helped. I mean, we don't know how many people died by eating, poisonous plants, but over the centuries, they came to the conclusion that some of these were. And that's what the authorities was able to show. He also recorded in his Materia Medica having gone to the Greek island of Lemnos, where he learned about terra sigillata, which was a type of clay. And as the story went, when it was mixed with the blood of a sacrificial goat, it was a very good antidote against poisons. Well, there is something to the clay. Clay has the ability to absorb substances, including poisons. The sacrificial goat didn't have anything to do with it. That was sort of just a bystander. And by the time that Galen, another ancient physician, Greek-Roman physician, visited the island, he found that they had given up the idea of the sacrificial goat, and they were just talking about using this form of clay. Well, clay is scientifically very interesting. It's a complex mixture of what we call silicates, and it has the ability to absorb substances. So that if you're dealing with some sort of poison, if someone has accidentally swallowed poison, they can be given powdered clay to absorb the material before it gets to the bloodstream. Or if someone has been infected with a type of bacterium called Shigella dysenteriae, which causes dysentery. Dysentery, of course, is this terrible bloody diarrhea that can dehydrate you very quickly and you can die. But the problem actually is that the bacterium produces a toxin, and it's the toxin that causes the symptoms. And clay can absorb the toxin. So to this day, the treatment of Shigella infection is using clay to absorb the toxin. Now, clay was used throughout history. I mean, it started way back with the ancient Greeks. But in the 16th century, a physician in Poland, Johannes Montanus, claimed to have found an improved version of this clay. And still calling it terra sigillata, it was widely promoted by Berthold, who was a former miner, in pill form. So this was just compressed clay, and it was given people mostly for diarrhea, and it actually did work. Of course, they didn't understand why it worked, but it did work. But there's a fascinating connection here to Wilhelm IV, Prince of Hesse Castle. And this was a state in what at that time was called the Holy Roman Empire, and he was the ruler. And he heard about this terra sigillata being an antidote for poisons, and he decided to test it. And this historically is one of the first ever recorded clinical trials. It was very interesting. It was done on dogs. He had his assistants take 8 dogs and gave them poison. Half the dogs were also given terra sigillata, this form of clay, and the other half were not. And it turned out that the ones who were given the clay survived, the others did not. Remarkable. This was in the 1600s. Clinical trial on dogs, very much like we would do today, where you use a randomized approach. You give some of the subjects the thing that you're testing and others not, and then see what happens. However, terra sigillata kind of disappeared from the public domain when the bubonic plague appeared, because it was supposed to be, the cure for everything, but it did nothing for the bubonic plague, because of course the bubonic plague is not a poison. The bubonic plague was an infection, and the terra sigillata could not do anything about that. So we started here, way back, island of Lemnos, thousands of years ago, with this terra sigillata, this special clay. It's still with us. We may have used it. If you've ever used KO, because the KO refers to kaolin, which is a type of clay, and the pectate is a soluble fiber. Both of these are very effective against diarrhea. So there is the modern version. I mean, of course, it's refined, the clay, compared to what we saw before, and it works. Unfortunately, it turned out that in some cases, it was not refined enough, and it was found to contain traces of arsenic, which is also found in the soil. That wasn't good. So now the ketopectate uses a different kind of clay called atapulgite, and instead of pectin, which we encountered before, and this works extremely well against diarrhea. So there you go. We started thousands of years ago with a claim of clay having fascinating properties, and it turns out it really does. But of course, modern science has improved upon it. And you never know where this is going to lead. First, it leads us to British Columbia, Kissimmee Bay, which has a special kind of clay. And researchers are now investigating this because it has been used for centuries as a medicine by natives in British Columbia. And what makes it interesting is that they are onto something here, because it turns out that this particular kind of clay is very effective against some drug-resistant bacteria. And you know that these days, this is a huge problem, drug resistance. Antibiotics are perhaps the greatest drugs that have ever been introduced in history. But the more you use them, the more likely it is that the microbes get used to those drugs and they will no longer work. So there's a constant search to try to find new antibiotics. And researchers looking at plants, soils, clay. Turns out this clay, British Columbia, is very possibly going to make it into medicine as a novel type of antibiotic to which bacteria don't develop resistance. Of course, eventually they will, because no matter what antibiotic you use, eventually the bacteria develop resistance. So it's always a question of being one step ahead of the game. Well, clay is, of course, a type of soil. And soil also has various minerals in it, which are also very useful. Now, if you look at this, what you're looking at here is a type of rock or an ore. And this particular one is titanium ore. This is from where we get titanium. Titanium is really an interesting metal. And there are some unique items that can be made out of it. I have one actually that I was given as a present after giving a talk. And it was this titanium pen, made off of titanium. But the really interesting part of this is how this titanium pen was made. This was made by a 3D printer. Molten titanium is put into this device, and it prints out a pen. It's remarkable when you watch this. Anyway, I'll show you in a minute the 3D printer. But titanium is a beautiful metal. It was, of course, one of the elements in the periodic table, and it was discovered a long time ago, back in 1791, by William Gregor in the ore that I just showed you. And that ore is actually called rutile. And what it is titanium dioxide. So it has to be refined. Titanium does not exist in nature as a metal. You can't go looking around for a chunk of titanium. It doesn't happen. So you have to take the ore, which is titanium dioxide. It has to be heated to drive off the oxygen, and then you have the titanium left behind. The name of titanium is interesting as well. It derives from the Titans of Greek mythology, who of course were legendarily strong, as titanium is. So the pen that I just showed you was made by this little device. It's about the size of one of these foam fryers, that you can put on your countertop, and you load it on top with molten titanium. You program it to whatever you want it to produce, And it does it. It just comes out. This 3D printing is an amazing business. It can be done with numerous materials, including many plastics. So you can make many plastic parts with a 3D printing. Amazing technological achievement. So what is the point, though, of isolating titanium and using it? Many commercial uses. It is extremely useful in some car parts because it doesn't corrode, it's shining, it will never rust. It is used in airplane engines, in many parts of the airplane, again for the same reason. It is also very light, so it's light, strong, and does not corrode. It also does not react with seawater, which is the reason that there's this titanium sub, which only the Russians have. And it is a very potent weapon because it requires almost no maintenance. It can stay underwater for months at a time. It's a nuclear-powered submarine. For some bizarre reason, only the Russians have been able to produce this. But you can see the shiny nature of the titanium. Because it is so strong and light, you can make bicycles out of it. This is not the kind of bicycle that you want to buy for your kids, because that bike is about $20,000. Okay? But this is the kind of bike that you'll see in the Tour de France. That's what they are riding, because there, a fraction of a gram makes a difference, in the weight. You can also make jewelry from titanium. There it is, very pretty titanium rings. You can make watches from titanium. And the largest piece of anything that has ever been made of titanium is in Moscow. And it is a titanium statue of who? Anyone recognize? It's not Putin, no. If you look at the shape, it should give you the shape of a rocket. That's Yuri Gagarin, exactly. The first person ever to fly in space, to orbit the Earth, and that is a statue dedicated to him in Moscow, and it is totally made of titanium, so you never have to worry about it rusting. It will be there for as long as the pyramids, unless someone pulls it up down. But there's another use of titanium that you have probably encountered, because I suspect some of you have had root canals. Yes? Well, when you have a root canal, which is actually a great example of modern technology, very often the tooth, even though you've done the root canal, will eventually die. And then it has to be replaced by a dental implant. This is one of the greatest breakthroughs in medical technology. They're really quite amazing. And the dental implant is made of titanium. Why? Because obviously it does not corrode, and also because it is totally compatible with body tissues. You know that the body has this ability to reject foreign substances. This is one of the big problems with implants, but not titanium. And this is why dental implants are made of titanium, and this is why hip replacements, hip joints, or knee replacements are made of titanium. It is strong, it will not corrode, it will not be rejected by the body. Amazing metal. Now you can take titanium and react it with oxygen and convert it into titanium dioxide, which is a white powder. You've all encountered this white powder because it is the main ingredient in paint. It is in virtually every paint, even the paint that is not white, because all paint starts out being white, and then pigments are added to determine whatever color that you want. So It is one of the most widely produced substances in the world, titanium dioxide. And there's another interesting connection. Another compound of titanium tetrachloride, is a liquid. That's what we have in this bottle here. But as soon as you open this bottle, the titanium tetrachloride reacts with water, moisture in the air, and it gets converted to titanium dioxide. It's a fascinating thing. You open the bottle and you see this smoke come out of it, which is pure titanium dioxide. This, believe it or not, has a commercial application. Probably not one that you would think of. It is in skywriting. So when you see an airplane that makes these interesting shapes, literally can write in the sky. It has a container of titanium tetrachloride in the tail, and that is slowly released, and it reacts with moisture in the air. Now, it depends on how long the pattern will last, depends on the moisture content of the air. If there is a lot of moisture in the air, you get a very intense reaction, right? Because you need moisture to react with titanium tetrachloride. If the air is very dry, then the skywriting doesn't work all that well. Now there's another connection of titanium dioxide, one that you may even have used today. What is that? Actually, toothpaste is not a bad guess. White toothpaste is indeed colored with titanium dioxide. Something else about the weather. Sunscreen. Many sunscreens today are based on titanium dioxide because it reflects light. There are two kinds of sunscreens that are used today. They're so-called chemical sunscreen and physical sunscreen. This makes me crazy because everything is made of chemicals, right? And to say that something is a non-chemical sunscreen is total nonsense. But there is a difference between the two types of sunscreens. The traditional sunscreens, what now are called the chemical sunscreens, absorb the light that comes from the sun, and they don't let it pass through to the skin. They absorb most of it. What happens with the energy that they absorb? It passed off as heat. So your skin actually gets warmer when you put on the sun lotion. The other type is the one that reflects all of the ultraviolet light. This is titanium dioxide. So none of the light passes through. It works very well. The only problem with it is that it leaves a white paste. Remember, probably when you were young, you remember what the lifeguards put on their noses? It was this white opaque stuff. But these days they've improved upon that by grinding the titanium dioxide until it becomes a very fine powder. And then you don't get as much of the white stuff, but it's very effective in terms of reflecting stuff. And these days, of course, that is becoming very important because there's one thing we know for sure, that excessive exposure to the sun causes skin cancer. You know that in the world of science, we very often have to use the word may. Whenever we're talking about treatment of something, we say, well, this may work. Here there's no may. Ultraviolet light causes skin cancer, period. Obviously, it depends on extent of exposure. There's no doubt about this. Then, of course, we're also dealing with the heat that comes from the sun. And there also lies an interesting story. When I think about heat that comes from the sun, my mind always switches to a Broadway musical because I like Broadway musicals. And 110 in the Shade is a classic Broadway musical. Anyone ever seen that one? Very, very good musical. It's maybe about 30 years old now. And it is all about getting very hot. It all takes place in the south, somewhere in the U.S. The stage always has a big sun in the background, and the show itself was based on a play written by Richard Nash called The Rainmaker. Very interesting. If you ever get a chance to see it, do that. Anyway, what's the connection here? The theme of that musical is a heat wave. Everything takes place. But this is not only fiction. As we know, heat waves really happen. And not only in the last few years. 1936 had the longest recorded heat wave in history. And that was even before we started to worry about global warming. I mean, there were hot years, throughout history. Of course, global warming is real. 10 of the hottest years in history have been during the last 12 years. The hottest year ever was 2023, average global temperature. Global warming is real, but there certainly were hot times even before. And the 1936 heat wave was a terrible one. As you can see, in the US, temperatures rose to above 100 in areas of the country where that had never ever happened before. And all the way from the south, as north as Syracuse, people flocked to the beaches if they could find a space on the beach. This was in New Jersey. If they couldn't make it to the beach, they slept in parks because there was really no air conditioning to any significant extent at that time. You had to find inventive ways to cool yourself down, like that. Take some blocks of ice, set up a fan the cool vapors that came off. Yes, this was air conditioning in the 1930s. There was such intense heat that across the country, pavements buckled. And you could literally, I kid you not, you could literally fry an egg on the pavement. There was an outbreak of locusts, of grasshoppers. And the weather was so hot that the grasshoppers literally fell from the sky roasted. They were cooked by the heat. So not only the grasshoppers died, people died as well. Hundreds of people. By the end of the heat wave, about 5,000 people in North America had died. And this was not only in the US, we got it in Canada as well. We saw unbelievable temperatures in Toronto, well into the 40s in Celsius. Manitoba, which you normally do not think of as having a cool climate, temperatures went up to 42 degrees in Winnipeg. Winnipeg. If you ever been to Winnipeg, you know this is not a hot climate. The coldest place in Canada, aside from the up north in the Arctic, is where? Famous corner in Winnipeg, Portage and Main. And I've stood on the corner of Portage and Main and experienced the winds there. So to have 42 degrees Celsius in Winnipeg was really remarkable in 1936. Well, how does the human body react to this? Of course we sweat, right? Why do we sweat? This is a way that the body cools itself. Because that liquid, which is mostly water, evaporates. If you're going to change a liquid into a gas, it requires energy. Well, that energy is taken from the skin in the form of heat. So it takes the heat from the skin and dispenses it. One way to think about this, if you've ever spilled a little bit of nail polish remover on your hand, how does your hand feel? It feels cold. Because as the nail polish remover evaporates, it needs energy to be converted to a gas from liquid, and it takes that energy from your skin, so you cool down. That's the protective mechanism that the body has. But there are negative things that heat does to the body as well. It changes the way that blood flows through the body. Because if the body can't cool itself enough just by sweating, the next mechanism is to drive more warm blood towards the skin so that it can interact with the air and dissipate some of the heat. So blood vessels dilate in heat. Now that can result in a dramatic drop in blood pressure. This is why people faint in the heat. And if it becomes extreme, you get heat stroke, and that can kill you. And it turns out that between 2000 and 2019, there were close to 500,000 heat-related deaths every year. Now, this is not something that you normally think about. You think of people dying from bacterial diseases, from cancer, heart disease. You don't think of them dying because of the heat. But this is happening. And of course, it is happening more and more as the global temperature increases. It's not the first time that we've heard about the consequences of dealing with extreme temperatures. If you remember, classic television show, one of the best shows ever, which was really Rod Serling's gem. In 1961, there was an episode, fictional of course, where the Earth went out of its orbit and got closer and closer to the sun. And it's getting hotter and hotter, and of course made life unbearable. And as you know, the Twilight Zone episodes always had a kicker at the end. So it turned out that it was all a dream, that she had been dreaming about this. Why? Because the world was actually cooling, and she was feeling very cold in her sleep. So she had dreams of hot climate, and then the episode ends by looking out the window, seeing that everything is frozen. So it was very clever. There were other episodes that dealt with heat as well. Alfred Hitchcock Presents in 1956 in an episode, Shopping for Death. It was all about a lady who was actually being driven crazy, behaving in a totally abnormal fashion because of the heat. But you see happening. This can actually happen. Another interesting connection was in 1989 in a film by Spike Lee, which was the story of two gangs fighting each other in Brooklyn, in New York. But it was all triggered because of the extreme heat wave, the temperatures. They were all becoming irrational because of the heat. It ended up in setting fires, terrible things. We know that extreme heat can make people crazy. It affects the way the mind works. And there actually have been studies of that, about cognitive function and how it interacts, how it affects the body. This was a very interesting study. In 2016, there was a heat wave in Boston, and researchers jumped on this and decided that this was a good time to investigate an idea he had, because there were some university residences that were air-conditioned and some that were not. So he decided to do cognitive tests on the students to see whether or not they performed differently in air-conditioned residences as the others, and indeed he found that they did. The ones who were in air-conditioned residences did better. Another study, very interesting one, was about PSATs. PSATs are exams that American students write in order to get into university. And in this particular case, the researchers found that there were significant differences in test scores depending on where, when, and at what temperature they wrote the exam. And the ones who had to struggle with writing in hot gymnasia did more poorly. So what do we do about the heat? Well, right now, you're sitting in air-conditioned comfort. few people know how this happens, right? How does air become conditioned? We go back historically to 1756 in Edinburgh, William Cullen, who gave the first demonstration of what eventually became refrigeration and became also air conditioning. And it was very interesting. And he noticed what I just alluded to earlier, the idea that if you take a liquid that can evaporate and you put it in your hand, it evaporates and it cools the hand down. He was the first person to notice this. Now, science works by taking small steps until eventually someone makes a leap. Well, the next small step was taken by Benjamin Franklin, who took small steps in many, many different areas. I mean, he was obviously a brilliant inventor. And he showed that if you took a thermometer and you put a liquid like alcohol on the bulb of the thermometer, the liquid evaporated and the temperature of the thermometer went down, because the evaporation of the liquid cools down the liquid inside the thermometer. It was at this point that Michael Faraday, perhaps the greatest scientist who has ever lived, picked up the baton and found that if you took ammonia, which is a gas, this is the stuff that you smell when you open your Windex. If you took gaseous ammonia and you compressed it to a liquid, and then allowed that liquid to evaporate, it would absorb huge amounts of heat. And this then was furthered by an American physician by the name of Dr. John Gorey in Florida, who put this to use. And he developed a machine that would compress ammonia, change it back into a gas, and as that happened, any water that was surrounding the ammonia would freeze. And he invented the first ice-making machine. That's what it looked like, a pretty complex piece of equipment. But historically, this was a brilliant idea. No one had ever been able to make ice before. Believe it or not, before this, they used to drag huge blocks of ice from up north down to here and even further south if you needed ice. In fact, it was such an important achievement that when Florida was asked who it should portray in the US Congress, in the US Capitol, there is a statue of the state's favorite son. 50 states, 50 statues, each of the states decided who would best represent their achievements, and Florida chose this physician, Corey, and a statue of him stands there in the US Capitol. And President James Garfield was shot in an assassination attempt. He was in the White House caring for the physicians, and for the first time ever, they used the technology that I had just described, where they used the machine to make ice and fan the vapors, the cooling vapors. Unfortunately, he didn't survive. He died from an infection because they probed his wound. They tried to take out the bullet without sterilization because they didn't know about sterilization in the face. But the first time that the public had a hint of air conditioning was in 1904 at St. Louis World's Fair, which up to that time was the largest World's Fair ever. And the Missouri Pavilion was the first building in the history of the world ever to be air conditioned. And this was due to the brilliant work of Willis Carrier, who is the father of air conditioning. And there's still a company, the Carrier Company, that makes air conditioners. Here is his original patent, but the principle is very simple. Whether you're talking about refrigeration, whether you're talking about air conditioning, the principle is the same. You always have a liquid or a gas that you compress to a liquid, and then you allow the liquid to evaporate, and when the liquid evaporates, it takes in energy from the surroundings. In a refrigerator, it takes that energy from the inside of the fridge, and of course with air conditioning, it takes it from the room and delivers it outside. Carrier's basic invention was the compressor, the pump, that was able to effectively change a gas into a liquid. That's what the original looked like. To give you another idea of how this works in a very simplified way, is this toy, which many of you have probably seen. The bobbing bird. You put a glass of water in front of the bird, you immerse the bird's head, which is made of a spongy material so that it gets wet very easily and holds the moisture. You immerse it in the water, and it will continue to bob. It seems like it's a perpetual motion machine. Of course, it's not perpetual motion because it requires the water. That's what it uses the heat of the water as energy. How does this work? Again, this basically is the principle of air conditioning and refrigeration. There's a liquid in here which readily evaporates, so goes up the tube. Because the head is wet, it's immersed in water, the water evaporates, but cools the head. When the head cools, the vapor that has come up from here changes back into a liquid, makes the head heavier, and the bird bends over. And it goes on like that. If you want to use whiskey instead of water, what will happen? Will the bird go slower or faster? Faster. Why? Alcohol evaporates much more easily than water. And if you want to see the bird go crazy, you use ether, which evaporates readily, and it will keep bobbing very, very quickly. So here you have the basic principle of air conditioners and refrigerators. It is really not all that complicated. It starts by taking a gas, compressing it, allowing it to evaporate. As it evaporates, it takes heat from the surroundings. That's how all air conditioners and refrigerators work. The key, of course, is a compressor. When your fridge breaks down, it's because the compressor has broken down. Of course, there's always the possibility that you get a leak and some of the gas leaks out. Anyway, air conditioning was used first in the 1930s in movie theaters. And that, of course, was a huge advertising feature. People flocked to the theaters in heat waves because it was the only place to be cool. And this is why movie companies released movies in the summer. That's why blockbusters to this day are released in the summer, because it was to get people to come into the air conditioning. And then eventually cars became air conditioned. That was much later. I mean, the universal air conditioning in cars really didn't happen until the 1980s. And then air conditioners started to be introduced into homes, of course, to the great satisfaction of people. And people were happy, about their air-conditioned cars and their air-conditioned homes. Until a problem cropped up. And the problem was that the liquid that they were using, which had displaced ammonia was excellent refrigerant liquid. But the trouble was that if you had a leak of ammonia, it could be deadly. So they replaced it with Freon. Freon is inert, totally safe, you could inhale it, no problem. And when you use an asthma inhaler that's in fact powered by Freon, there's no problem inhaling Freon. But it turned out that when it escaped from air conditioners and refrigerators, which inevitably happens when they were disposed of, it made its way to the upper atmosphere, where it interfered with ozone. And the ozone layer in the atmosphere is what protects us from being overexposed to ultraviolet light. No one had ever thought about this. How would you even think about this? You know, hindsight is always 20/20. How in the 1930s could anyone have ever thought that 50 years in the future, freon would be found in the upper atmosphere destroying the ozone layer? How could you, that thought would never cross anyone's mind? So anyway, the original freon was called freon 22, and it worked extremely well, except it got into the upper atmosphere. And this is why a convention was held right here in Montreal to deal with this problem. And out of this emerged the so-called Montreal Protocol, where countries agreed that they would eliminate the specific chemicals or specific freons that interfere with the ozone layer. And of course, that created a lot of research opportunities to find substances that would not do the damage. And a number of these were developed. Something very interesting to note here, you see that the chemical formula is not very different from the one that I just showed you. So very small changes in the structure of a molecule can have a huge impact on what happens in the world. I mean, this is one of the fascinating aspects of chemistry, that small changes can have macroscopic effects. So right now, the refrigerant that is used in your home refrigerators and your air conditioners is this one, which has a much, much smaller effect on the ozone layer. It's not a zero effect. It can still have an effect, but the problem has been dramatically reduced just by changing the molecular structure of this refrigerant just a little bit. Well, finally, you're going to hear a lot more about the problems of air conditioning with the Olympics in Paris. Because this is deemed to be, or it has been said to be, the greenest Olympics. What that means is that they are trying everything to reduce their use of energy, including in air conditioning. So the residences for the athletes are not air conditioned. So what they have done instead is they have pipes in the floors through which cold water circulates that at least keeps the temperature down a bit. But Paris in August and end of July is going to be very hot. So both Canada and the US have decided that they will take portable air conditioners, and every Canadian and American athlete, the room will be air conditioned, because they have decided that this is going to make a huge effect on their performance. Because as I mentioned to you earlier, the high heat affects the way your blood circulates, it affects blood pressure, it affects muscles. So we'll see whether or not the air conditioning benefits the Americans and the Canadians, although other countries may also decide to use their air conditioning systems. So anyway, that's our story for today. And you can see that it dealt with many interesting things, starting with the ancient Egyptians, you know, and how they recommended the use of roast liver to cure night blindness, with Terra where medicinal clay was used to absorb poisons, which is still used today as K-peptide. And you know, then we got into some aspects of climate change, etc., to kind of give you a picture of all the interesting areas where science plays a role. All right, so if there are any questions, we can try to handle them, yeah. Yes, when we say that clay is a very absorbent material, it doesn't mean that it absorbs everything. The aluminosilicate, of which it is composed,
basically form tiny little holes. If you were to look with a very strong microscope at clay, you would see little holes. So it depends on what can get into those little passages. So it basically depends on the size, molecular size of the poison that you're talking about. But clay, of course, is not the only material that has this absorbent property. Charcoal does that too. So, for example, charcoal will, be stored in all emergency rooms. So, if someone comes in with some unknown poison, the first thing they do is get that charcoal because it will absorb a lot of poisons. Yeah. Because we're all biochemically individual. The question is how heat affects people differently. First of all, your body can handle heat differently. It depends on your body size, for example. The surface area of your skin is what determines how effectively sweat will evaporate from your body, right? So the higher the surface area of your skin, the faster you can cool down. But also people have different sensitivities, they don't notice heat the same way. Yeah. The question is how do animals know which plants are good with them? The fact is that they don't. I know that there are a lot of stories circulating about monkeys and chimpanzees when they feel sick seeking out certain plants. This is a very rare thing. This is not universal in the animal kingdom. Animals do not seek out specific. They have learned, of course, what is poisonous and what is not. Because if it's poisonous, they die, right? And they don't have offspring. But in terms of actually seeking out, there is few examples of chimpanzees which, when they have some sort of bacterial infection, actually seek out certain leaves. Although it's not universally accepted that this is happening. So no, animals are not good at medicine. People are better at it. Yeah. Yes. Yes, except that it's refined. Right? I mean, in the ore, the rutile, the titanium dioxide is mixed with iron oxide, it's mixed with many other minerals. So it has to be refined. Pure titanium dioxide is white. Titanium is pretty expensive. Yeah, like I told you, the titanium pipe, $20,000 or so. And if you ever had a tooth implant, a titanium tooth implant, for about $3,000 for that implant is for the titanium. The catalyst in your car, the active catalyst is actually palladium and platinum, but the container in which these are, that's made of titanium. And that's one of the reasons that the field catalytic purpose, because it's got all these metals. Yeah. The user zirconium, yeah, for. Oh yeah, zirconium is another one of these metals, very much like titanium. It's unreactive, doesn't corrode. It is even harder to extract than titanium. Anything else? Yes. Yeah, any liver. All liver is rich in vitamin A. Yeah. But you always hesitate to recommend eating of liver because the liver is the body's organ that detoxifies. So it is also the organ in which whatever toxins you've been exposed to gets concentrated. You don't have to eat liver to get your vitamin A. All meat contains enough vitamin A. Nobody here has to go out of their way to eat liver. Eat liver if you like it, not as a therapy. Yeah. I don't know what doctors encourage you to take vitamin A. Really? Are you sure? Vitamin A? Vitamin D? Okay, right. That's a different story there. Yeah. No, I don't think any doctors should be encouraging taking vitamin D, absolutely. Yeah. Sorry? No, there's plenty of hype anymore. It's the work needed to get it out of the oven. Yeah.
That's what I'm thinking. Maybe Thursdays are better.
It's not on the market. It never made it. So you're still at risk for putting ketchup on your hamburger and squirting it in your face. Yeah. It's trial and error. I mean, until they hit upon the fact that liver would treat night blindness, God knows how many other things that they tried. And remember, we're talking about, like with Eber's populars, we're talking about discoveries that were made over hundreds of years. Not one day ago. Yeah. Yeah. Well, I mean, this is something that you expect with any new drug. As it becomes more and more used, you will find things that you would never have found in the clinical trials. But the blindness thing is Ozempic. It's such a rare phenomenon. You're talking about cases that are counted in 1 per millions. But it's not surprising. I mean, the more and more people will use Ozempic, the more and more you will find that there's some side effect that was not revealed by the clinical trials. Because no matter how good your clinical trials are, what are you using? At most 3,000 subjects. I mean, that is already a huge clinical trial. So, if you have side effects, which are, 1 per 100,000 people, you're not going to find them in your clinical trial. But when you have millions of people taking the drug, of course you will find them. So, it's not surprising that we keep finding side effects as drugs get more and more used. When? Well, would you worry if you know that 1 in 5 million people have this effect? Only if you're the 1 in the 5 million. When? It's possible. I don't know. I didn't look at the stats. But, Ozempic is a serious drug. I mean, you take Ozempic really because obesity affects your every other disease that you can get. It affects your life expectancy. So, how does Ozempic work? Ozempic produces a hormone which is very similar to the hormone that the body naturally produces. Okay, let's go back a little bit. How do you know when you should stop eating? Right? Many people, of course, don't. But most people will know when to stop eating. And that is when you're full. But how does your brain know that you're full? Because your gut, your intestine, sent a signal, needs of a hormone to the brain saying, okay, we're full, this is enough. Semaglutide, which is the active ingredient in Ozempic, mimics that hormone. So when you're injecting it, what you're really doing is telling your brain, okay, it's not enough to eat, even though you have. Because semaglutide is a fatty hormone. It's a fat soluble hormone. So if you would inject it into blood, which is mostly water, it will get carried around because it's not soluble in blood. So it's has to be injected into fatty tissue. And also from the fatty tissue, it directly affects the brain because nerves have a fatty layer on the outside, a fatty sheath, and the Ozempic travels through that. All right, so we'll see you in August.